So all of that was building just so that we can get to basically this step where we're given a sentence, and now we can translate that sentence and graph that function. So really, this sentence is describing a function that we can put onto the graph. And the whole point of this, the graph, is an easy way to visualize what's actually happening in that sentence. All of these word problems, all these practical, real math problems can be solved and visualized with a graph. It tells us a lot more looking at a picture than looking at just a scattering of numbers. Or a sentence, actually. That's even the most vague way of seeing it. So first we have to translate it into an equation. Then we're going to make it into a table of points. And then from that table, we're going to graph. So the output is 2 more than double the input. The output, that's our y. That is 2 more than double the input. That's 2 times our x. Our input is our x. It's 2 times. We do need to rearrange that order. We see that phrase more than is 2 more than something. So I'm going to flip the order of that. Y equals 2x plus 2. From there, I'm going to take that equation and plug in each of these x values. Each can go into that so that I can eventually graph some points. When I plug in -1, it's -1 times 2 plus 2. -1 times 2 is -2 plus 2 is 0. -1, 0 is one of the points on this line. When I plug in 0, 2 times 0 is just going to be 0, plus 2 is 2. Or the point 0, 2. And then I plug in 1, 2 times 1 is 2, plus 2 is 4. So 1, 4 is my third point on that line. Now I'm going to plot 1, 4, 1, 2, 3, 4, 0, 2, and -1, 0. If it doesn't form a straight line, something went wrong. Each of these, when you have an equation like that, it should form a straight line. Like those two. Every time they should line up perfectly like that. And you want to graph at least 3 points on a line to confirm that you're getting a straight line. 2 points, don't draw this, but 2 points will always form a straight line. Those 2 blue points will automatically form a straight line. It doesn't matter if I graph one of them wrong. That will still form a straight line. But when I do 3 of them, I can tell that those are not going to line up. So I must have done something wrong. Maybe it looked like that, and they actually do line up now. All right, on number 2, y equals the quotient of x and 2, so the division problem between x and 2, plus 1. So now I have my equation. I'm going to take that and use each of these x values in there to find my y values. I'm going to plug a -4. That gives me -2 plus 1 or -1. So -4, comma 1, sorry, -1 is one of my points. -4, -1 is a point on the line. I plug in 0, I get 0 plus 1, that's 1. So 0, 1 is another point. 0, 1 is my second point. Then I plug in 4, I get 2 plus 1, that's 3. So 4, 3 is my final point, and I want to make sure that those actually line up. 1, 2, 3, 4, 1, 2, 3. That looks good, but since I have a computer to help me, I want to make sure that those actually line up. Yep, that makes a perfectly straight line. All right, for each of these, I want you to graph them on your own, but I am going to translate them for you just to help you with setting up the equation first. The dependent variable will be y. Oops, that actually made a y anyway. The y is -4 times the independent variable. We don't have to change the order of that. That is just y equals -4x. Y equals the difference of 2 and x. It's happening in that order. There's no switching words. It's just y equals the difference 2 minus x. Difference means subtracting, and it happens in that order. The dependent variable, or the y, is 3 less than 4 times the independent variable. 3 less than. That's one of those switching phrases. Less than is telling me I'm actually taking that 3 away from something. I start out with something, and then it's minus 3. And the thing that I start out with is this 4 times the independent variable, or 4 times the x. And the last one, the output, is the y is 3 times the sum. This is an important phrase, 3 times the sum. It's not just 3 times something, it's 3 times the addition problem. 3 times this. This is one thing, the sum of 1 and the input times some addition problem, 1 and the input being added together. I'm going to write that a little bit cleaner in my next part. 3 times, really we're going to distribute there, times 1 plus x. The 1 plus x is the sum part. It's 3 times the entire sum. When you plug in these numbers, actually don't distribute. If you were to simplify this, you would distribute, but since we have numbers to plug in, you just follow PEMDAS, so you're going to do in the parentheses first, then multiplication. That's just a little bit easier. Alright, so go back and graph these 4 before you move on to anything else.